Building generative AI solutions are really the de facto conversations these days when you talk about leveraging AI in an enterprise. Now, it's not a simple exercise to just go and get a provider API like connect to OpenAI APIs and start to get benefit out of it. Most of the times you would need an organizational context, and I've talked a lot about that using RAG architectures. I'll put the link somewhere up. This video is about sharing some of my learnings and experiences in building systems around generative AI. And I want to focus on few specific areas as to how can you manage your data pipelines better to be able to feed them into some sort of a search service and finally drive it towards generative AI. So here's a mental picture. You have a lot of data and think of it like this cable. So it's completely tangled up. It could be unstructured, structured, sitting in different formats. You might be looking at logs, you might be looking at PDFs, you might be looking at customer chats and all of that. So there's tons of different kind of data available. And I don't think I need to get into the details of how to manage data lake and all of that. That's a conversation for another day. But what's likely to happen is you have a wide variety of data and you would want to make sense out of it. Second, and on the extreme right hand side, you have the whole AI setup. You have an OpenAI API connection. Maybe you're using AWS and services like Bedrock, where you are using Anthropic or whatever provider you end up using in terms of APIs. And there's only a few of them in the market. You'll probably use Gemini, OpenAI, or Anthropic, and few of these players in the market. If you're not into a specialized domain which has a fine-tuned LLM. So on the extreme left, you have data, and on the extreme right, you have a lot of, these providers that are coming in. And somewhere people are saying a word which is called RAG architecture, which is retrieval augmented generation. And it's a mouthful, right? What essentially you're trying to do is before asking a question to an LLM, you want to give it your organizational context, which is sitting in form of a data. So what you're doing is getting the data from the left, bringing it into a place, vectorizing it, feeding it into some sort of search service, indexing it, depending on what kind of operation you're doing, and then finally sending that data, augmenting that data with the query so that the LLM has organizational context. It's very much possible that this gives great results, and for some specific domains where you have sensitive data, where things like healthcare, things like finance, you might want to get into fine tuning, but again, that's a conversation for another day. So the idea is you want to, I just have this, I'm going to play with this. So the idea is you build some sort of a pipeline which is a very seamless flow of data, having your organizational context as well as feeding it into an LLM and being able to build RAG. So how do you do that? I think the first set of exercises are around getting into and understanding that how have you built and kept the data? What are the different data stores that we want to leverage in order to bring it into the AI conversation? Now, this first level of chunking could help reduce and eliminate a lot of waste. Otherwise, what will happen is the volume of the data that you'll feed into to indexes would significantly grow. And as you start to feed more volume into indexes for these search services to work, which is how most of these cloud providers are positioning their services, the cost of indexing would go up, right? And you also don't want to keep on periodically indexing this data. So how you index the data is a very, very important conversation to have. The second part of the conversation is what sort of data do you actually convert it into vectors? Now, vectors are cool. It's like any other data type. My opinion is as we graduate more in this world of AI driven systems, very similar to, NoSQL becoming a de facto data type for a lot of kind of applications, vector databases and vector data types would, kind of rule the world. So a choice of a good vector store, you can use PG vector, you can use Redis vector if you're already having Postgres and Redis, or you could be going to Pinecone, etc. That's a completely reuse, build, buy conversation. But after these indexing, a vector store comes in. And all of that has to be orchestrated by a set of APIs, and you have mostly some frameworks like LangChain or Llama Index sitting in. Now, when you build this orchestrator, right, the service design is also important. You might want to leverage technologies like Kubernetes to be able to scale it out. And finally, when you tie all of this together into a neat picture is when you will get RAG architecture. So summarizing the best practices and things that have to be paid extreme importance is, how are you handling your data, your original set of data pipelines? How are you storing that data? Do you have data quality conversations in place? Next, how are you indexing the data? And when you are indexing, what are the factors and parameters you're considering? How often do you need to refresh those indexes and stuff like that? Moving forward, how much data you want to store as vectors. That's also something to be thought around, what sort of products you end up using. And finally, the service design itself, that also becomes a conversation to be have. How do you scale those services? What are the connections it needs to have, etc. Underlying all of this, it's important to have an observability pipeline. And observability is kind of going to help you get a picture into what services are achieving how much cost, what's the latency in responses to the user, how many tokens are getting used, what's the quality of responses, etc., etc. So that's a little 2 cents around how could you design better generative AI pipelines. If you like this kind of conversation, put in thumbs up and I'll do more of monologue kind of conversations. Until next video, bye bye.